Hello students, in this video I will give the explanation of the derivatives. And first let us come to the definition of the derivative, and later let us understand geometrically what is the meaning of the derivative. See here, suppose f is a real valued function and a is a point in its domain of definition. The derivative of f at a is defined by limit h tends to 0 f of a plus h minus f of a divided by h. This is the definition of the derivative. The derivative exists if this limit exists. Here limit exists means both left hand limit and right hand limit are equal. Just note here f of a plus h minus f of a is constant. Here variable is h and h is tends to 0. That means instead of x tends to 0, here h tends to 0 is there. H tends to 0 from the positive side as well as negative side of 0, that is 0 plus and 0 minus. Both of them should be equal. Now, to understand the concept of derivative, you take the curve. There is one curve y is equal to x square plus 2, and if you draw the curve, it is a parabola and it is like this. And let us take a point P on the parabola, and the coordinate of P is a comma f of a, and f of a is the value of the function at x equal to a. And you take a point Q on the curve such that coordinate of Q is a plus h comma f of a plus h, that is, and this height is f of a plus h. Now in this triangle, and you can observe what is tan of psi. Tan of psi is opposite side divided by adjacent side, and this side is f of a plus h minus f of a, and adjacent side is h, and thus you will have tan psi is equal to f of a plus h minus f of a divided by h. Suppose this angle is psi, and if you draw a line which passes through PQ, and angle made by that line with the positive x-axis is also psi. And therefore tan psi give the slope of this line joining PQ. Here line joining PQ is chord of this parabola, and tan psi gives the slope of this chord. Let us understand what is the meaning of limit h tends to 0 f of a plus h minus f of a divided by h. Now you see this video, and suppose psi is the angle made by the chord AB with the positive direction of x-axis, then tan psi gives the slope of this line, that is slope of the chord AB. And you know that the tan psi is equal to f of a plus h minus f of a divided by h. And as h tends to 0, when h becomes smaller and smaller, what happens you observe. I will decrease the value of h, and you can observe the angle of inclination reduces, and the slope of this chord, if you just observe the chord and a tangent, as you decrease the value of h, the chord will become almost a tangent. When h is tends to 0, this difference is h. When h tends to 0, this chord will become a tangent. That's why if you find limit h tends to 0, f of a plus h minus f of a divided by h, it will give the slope of tangent to this curve at this point, and which is the geometrical meaning of the derivative of the function. Just see here, the chord will almost become a tangent. And when h is very small, when h is tends to 0, this chord will become a tangent at this point. Now I will take one problem. Find the derivative at x equal to 2 of the function f of x equal to 3x. First let us use the definition of the derivative of the function. That is f dash of 2 is equal to limit h tending to 0 f of 2 plus h minus f of 2 divided by h. And you know that f of x equal to 3x, it is given. And what is f of 2 plus h? In place of x, 2 plus h is there. That's equal to limit h tending to 0, 3 into 2 plus h minus 3 into 2. F of 2 plus h is equal to 3 into 2 plus h. F of 2 is equal to 3 into 2 divided by h. That is equal to limit h tends to 0, 6 plus 3h minus 6 divided by h. 6 gets cancelled, and that is equal to limit h tending to 0, 3h by h. And now h gets cancelled, and limit h tends to 0, 3, which is equal to 3. Now suppose f is a real valued function, the function defined by limit h tends to 0, f of x plus h minus f of x divided by h. Whenever the limit exists is defined to be the derivative of f at x, and it is denoted by f dash of x. Here x is a variable, and while finding the derivative we take it as a constant and find the limit of this function. And thus we will have f dash of x is equal to limit h tends to 0, f of x plus h minus f of x divided by h. And you remember this result. And sometimes f dash of x is denoted by d by dx of f of x. And suppose y is equal to f of x, and it is denoted by dy by dx. See here, this is the notation for derivative of y with respect to x. And while writing the derivative of the function, d by dx of a function, and this should be together and it should be written like this only. And it is also denoted by d of f of x. These are the three different representation of the derivative of the function y is equal to f of x. And with this much I'll conclude this video. In the next video, let us find the derivative of some standard functions by using the formulae which is called first principles. Thank you.